This lesson is about distribution. Distribution simply means multiplication. It's when you multiply a term in front of a parenthesis, such as a 5, times every term inside of the parenthesis. I like to use lines, I call them rainbow lines, to show that I'm multiplying the number in front of the parenthesis times every number inside of the parenthesis. If the term in front is negative, remember your rules for multiplying negatives. A negative times a negative is positive, whereas a negative times a positive or a positive times a negative is negative. So in this example, negative 3 times positive 6 gives you negative 18, and negative 3 times negative 7 gives you positive 21, and negative 3 times, there's a 1 in front of that x, is negative 3, and negative 3 times negative 9 is positive 27. If the term in front has a variable, then you multiply the numbers times the numbers and the variables times the variables. So the 2 times 5 is 10, 2 times negative 7 is negative 14, and 2 times 8 is 16, whereas the x times x squared is x cubed, and the x times x is x squared, and the x times z is xz. Note, if you multiply two different variables, you write them together, such as x times y is simply xy. If you multiply the same variable, you use an exponent, such as x times x is actually x squared. In general, the exponent's rule for multiplying the same base is x to the m times x to the n equals x to the m plus n, such as x squared times x cubed is really you add the 2 plus 3 to create x to the 5th. Here are some practice problems for you to do. Hit pause and take a moment and try them out. Then you can go to the next page and take a look at the answer key. Next, factoring is the opposite of distribution. If distribution is multiplication, factoring is division. Factoring is when you divide a common term out of an expression and place it in front of the parenthesis. So it is just the opposite of what we are doing with distribution. The common term you take out of each term is called the greatest common factor, or GCF. In this example, 10, 15, 5, and 5 all have a GCF of 5. So we bring the 5 out in front of the parenthesis and divide 5 out of each number. So 10 divided by 5 is 2, and 15 divided by 5 is 3, and 5 divided by 5 is 1, and so there is an invisible 1 in front of the z, or you can just not write the 1. Finally, 5 divided by 5 is 1. If the first term of an expression is negative, you must factor out a negative from each term. This has the result of changing the sign of each term inside the parenthesis. So for instance, the leading term is negative 18. So we will be factoring out a negative. So first find the GCF. 18, 21, 24, and 27, they are all divisible by 3. So our GCF is a negative 3. So negative 18 divided by negative 3 is positive 6. Positive 21 divided by negative 3 is negative 7. Negative 24 divided by negative 3 is positive 8. And positive 27 divided by negative 3 is negative 9. If all of the terms in the expression share common variables, you must factor out the common variable also, such as x cubed, x squared, and xz all have an x in them, so we bring out an x. 10, 14, 16, they are all divisible by 2, so the GCF is 2x. In this example, x to the 5th, x to the 4th, and x cubed, they all have an x cubed within them, so we divide out an x cubed, leaving behind the remaining x variables of each expression. The last number, 7, has no x's left, so it's just a 7. Likewise, in the following example, x to the 4th, x cubed, and x, they all share one single x. So we bring out a single x, leaving behind the remaining variables of each expression. Here are some more practice problems. Factor out the GCF from each of the following terms. Remember, your GCF is going to be numerical, such as if all the terms are divisible by 8. Your GCF will also include a leading negative, if there's a negative on the front term. Try them out, hit pause, and go to the next screen for the answer key.